Now we'll start talking about the third fundamental space of linear algebra. We've already talked about the row space and the column space. We now get to the null space. And what is it? It's the set of all possible x's where this equation could hold. It's all the x's that would make ax equals 0. Let's go back to the previous example. After we've done Gauss-Jordan elimination, here's our new sort of ax equals 0. The pivots are highlighted here. This guy is 5 by 7, 3 pivots, 3 non-zero rows. Lay out those, the columns. The linear combination of the columns equals 0. We'll get as many scalar equations from this as we have pivots, or the number of non-zero rows, or the rank of A. That's how many scalar equations you'll get. And if you look at this one, x1, if we move all the other guys to the right, there's an x2, nothing there. Let's see, this is 2x4, nothing there. 3x6, 4x7, etc. You get 3 equations for the pivot variables. These are the variables that correspond to the pivot columns. In this case, they were 1, 3, and 5. And note, we did Gauss-Jordan elimination, which makes it easier because this x3 doesn't show up in the x1 equation. It saves us some algebra. So how do we find a basis? Use the 1-0 trick. All of these guys are free variables. 2, 4, 6, and 7 are free variables. Remember, there was 4 of them. We went through this. We're talking about column space. So first, let's see, I guess we'll set x2 to 1 and the other guys to 0. When x2 is 1, x1 is minus 1. And all these guys are 0, so x3 and x5 will also be 0. Now we'll set, I guess, x4 to 1 and the rest of them to 0. So x1 will be minus 2. x3 will be minus 5. And everything else is 0, etc. I'm using the 1-0 trick. Just going through each of these 4 free variables one at a time, setting 1 to 1 and the rest to 0. And this is what you get. The dimension of the null space, or the rank of A plus the dimension of the null space, is n, the number of columns of A, same as the number of variables. That little relationship is called the rank nullity theorem. So the dimension of the null space is n minus the rank. So we have a way to find the dimension of the null space and a basis for the null space.